Good morning, 8th grade. This is Miss Odell, and we are going to begin our lesson this morning on section 1.2. You should have your sheet to fill in the notes, but I do want to let you know that if you were here and I gave you 1.2 yesterday, that it has changed a little. So go ahead and use the one that you have, but just make notes on the additional things that are not on there. Otherwise, if you didn't get a copy and you download a copy of the guided notes, then you'll have them there to fill in. Make sure you get these filled in, and you actually put them behind the notes tab for today. All right, so this lesson is on scientific reasoning. All right, so scientific reasoning. What is scientific reasoning? It's when scientists uses reason to develop a hypothesis from scientific laws and theories of observation. All right, so what is reasoning? You may be asking yourself, so what is reasoning? Well, reasoning is the process of thinking clearly to form a conclusion. Okay, so it's a thinking process that you would use to form a conclusion. Now, you also need to understand what logic is, okay? And logic is the study of reasoning. So one that would be studying reason would be studying logically, okay? Now, proper reason also involves inference, okay? It involves taking evidence, which are facts that you've already known, and you use them to make an inference, which is a conclusion based on reasoning from the evidence that you have already gathered. Now, there are two main branches of logic, okay? There is deductive reasoning and there is inductive reasoning, which we'll get to on the next slide. All right, so deductive reasoning. Well, that is the reasoning from evidence to a more specific conclusion. So the reasoning from evidence to giving a more specific conclusion. It is used here to combine the known facts, which are the evidence that you've received, to discover a new fact. Okay, for example, thunder. Thunder is always caused by lightning in thunderstorms. So in other words, if there is thunder, then there is a thunderstorm nearby. Okay? Proposition. All right? So proposition here is talking about a state of fact. Proposition is a state of fact, basically. In other words, if there is thunder, then there is a storm nearby. So then you have your hypothetical propositions that uses two parts as a condition. If it begins with if, then it's called an antecedent. If it begins with then it is called a consequent. Okay? Now, moving on to inductive reasoning. Now, inductive reasoning is reasoning from specific evidence. And you know what specific means. It's specific evidence to a more general conclusion. And of course, the ultimate purpose here is to determine the cause and effect by comparing the two different situations. Okay? Now, inductive reasoning, one important note here is that it can never prove a hypothesis beyond all doubt. Okay? It can never prove a hypothesis beyond all doubt. In other words, there's going to be some doubt there. Then you have two reasons for the conclusions to be valid. The first one is repeatability, and that means that you repeat the experiment multiple times, keeping all the factors similar, maybe not exact same, but very similar, and you will get the same result. So if you repeat that experiment over and over and over, keeping the factors very similar, then you're going to get the same conclusion. Reproducibility means that others will reach the same conclusion by performing the same experiment that you did. Okay? Moving on here. Now, we are going to talk about some scientific models here. and you will find those on page 9. This is in your a look closer, so it's like in the tan looking color. Now, what is a model? Before we talk about these various models, what is a model? A model is anything that provides a partial representation of something else. You know, like if you build a model car, it represents something else that is larger more than likely, and it is a model of it. Now, there is a model called a physical model, and that is when an object has the same shape and appearance as the object it appears. It may not be the same size, but it is the same shape and has the same appearance. A scale model is a physical model that is typically either larger or smaller than the object represented. Then you have a verbal model. A verbal model is a model that represents an object using an image or serves as an image. So it basically represents an object. And then you have a mathematical model, and that is a model that consists of equations and formulas. Typically, these models are used in science to describe like relationships between variables. All right? Keep in mind that models will never provide a complete picture of what it represents, okay? Now, I do want to add a little bit of information here that is not included, so just jot this down as I talk through it, okay? So, if you look at page 9, you see the term post hoc fallacy. It's spelled like this, post hoc fallacy. Well, let me back up here because this is 2 words, okay? So, or 3 words actually. Okay, so when you are using inductive reasoning, it's important to avoid post hoc fallacy, okay? So when you're doing the inductive reasoning, it's important to avoid this. Okay, when you're using inductive reasoning. Now, think about the word fallacy, all right? So fallacy comes from the Latin word meaning after this. Therefore, because of this, someone commits a post hoc fallacy when he assumes that a change in one factor causes a change in another, okay? A post hoc fallacy is very easy to make when performing like simple observations of nature. So when a fallacy is assuming without further evidence that something caused what happened after it, okay? So basically you want to remember to avoid this when using inductive reasoning. And so basically make sure you got that, and that fallacy is after this. All right, guys. So I would like for you to complete questions on page 10. And this is your section review 1.2, and I would like for you to do 1 through 7 on paper and turn in. Okay, guys. Hope you're happy.